When you arrived in Munich, Sommerfeld was just working out his quantum theory of free electrons.
Not quite.
Yeah.
When I arrived in Munich, it was 1926.
26?
26.
Ah.
And the big thing was that quantum theory, for the first time, was on a firm basis from Heisenberg and especially from Schrödinger. And Sommerfeld loved Schrödinger's wave mechanics because that was the sort of thing, differential equations with eigenvalues, the sort of thing that Sommerfeld had loved for a decade or two. And he gave a special course for graduate students on the differential equations of physics. And Schrödinger fitted right in, so we all were asked to take one section of Schrödinger and give a seminar on it. And so that's how I learned some Schrödinger's perturbation theory, because that was the section I was to give in the seminar.
But then when he came to applying it to solids...
Now in 27, a year later, he applied it to solids.
Right, and at that point he decided the electrons could be treated as free.
Well, he was very much impressed by papers by Drude early in the century, in which Drude had used classical mechanics and free electrons. And Drude just assumed the electrons must be free. If they are to conduct, they better be free. And Sommerfeld assumed that likewise in quantum mechanics. Neither of them had proved that the electrons indeed were free. That was only done by Bloch about a year later, and only in quantum mechanics. You cannot prove free electrons in classical mechanics, but in quantum mechanics, Bloch proved that the wave function of an electron was a plane wave multiplied by a function which was periodic with the period of the lattice. And Bloch, in a way, was the fundamental origin of the free electron picture.
So Bloch, in a sense, vindicated